led the demonstration and the validation of the whole SELFY toolbox in relevant attack scenarios, and we assessed the results and the impact to the CCAM, Cooperative Connected and Automated Mobility ecosystem. Therefore, we focused on several key areas. First, we identified the relevant scenarios for laboratory, for simulation and for the real-world tests. Therefore, on the one hand, we ensured the continuous integration of the project results. On the other hand, we designed, implemented and applied the validation tools in different validation scenarios, meaning simulation environment, laboratory environment and also the real-world environment. We defined a detailed plan, including test cases for the simulation, laboratory and real-world validation. For validation in simulation, laboratory and real-world, we focused a structured approach. First, we did some basic tests, for example, with synthetic data, then executed very simple combinations of integration tests, and finally executed the whole validation based on the use cases we identified in these diverse environments, meaning simulation, laboratory and real-world environments. Moreover, we regularly reported and documented the test results in a centralized way to ensure the transparency and the alignment. The project was divided into 2 iterations. In the first iteration, we focused on the overall validation planning, that the tools are ready for being validated in simulation in the selected scenarios. The second iteration focused on the use case-based validation as the final validation step across the selected scenarios and the environments like simulation, validation and also the real-world tests. Finally, we concluded with an assessment of the outcome of the validation for the CCAM domain. We successfully planned and executed tests at different levels, meaning basic tool tests, small integration tests, and finally the use case-based integration tests as the final validation. Also across different environments, meaning simulation, laboratory and real-world environment, and related to different scenarios, attack scenarios that were selected in context of the CCAM environment. The verification and the validation of the SELFY tools is a very important step to improve the resilience of the CCAM systems against cyber threats. The SELFY project collaborated with several CCAM entities to ensure the effectiveness against cyber threats. Our work addressed relevant CCAM scenarios, leading to refinement and improvements for the deployment of the tools in the near future.